Hello guys, welcome back to CEBOX tutorial channel, and this is our situation number 69 for CE board exam November 2022. But before we start to solve this problem, don't forget to subscribe and hit the bell icon for notifications and updates on our YouTube channel. A wooden log is to be used as a footbridge to span a 2-meter gap. The log is to support a concentrated load of 40 kN at mid-span. The allowable shear stress is 1.2 megapascal and the allowable bending stress is 6.3 megapascal. So, itong topic na to is under sa bending stress and shear stress ng beam. Okay? And it is under sa strength of materials chapter 5 na topic. So, kung gusto niyo ng detailed discussion and step-by-step procedure ng mga problems sa pag-solve ng bending stress and shear stress, you can visit our playlist. So don't worry, yung link naman ay naka-provide sa video description. So number 1, calculate the diameter of the log needed for maximum shear. So drawing na lang natin muna siguro yung log natin. Ayan. Ano ba nakalagay? Okay, footbridge. Pero walang sinabi kung ano yung yung kanyang magiging type of support. Pero pag bridge kasi, ang support natin dyan ay simply supported. So, isang pin, then isang roller. Tapos, yung span na i-cover ng ating log is 2 meters. So, for number 1, yung ating cross-sectional area ay circle. Bakit? Kasi diameter yung pinapahanap. Then, balikan natin yung equation for shear stress. That is equivalent to BQ over IB. So, this is neutral, this is moment of inertia with respect to neutral axis. Then, yung ating B is yung width ng ating section kung saan natin kinukuha yung maximum stress. So, ang ating maximum stress kasi rito ay nakalocate sa neutral axis. Ayan. So, dito yung ating neutral axis. Diyan rin natin kukunin yung ating diameter ng log based on our shear stress. So, therefore, ang ating B is yung diameter mismo nung ating log, which is yung sinasolve natin. Okay? Then, ano ba yung ating I? Ang I natin kasi for circle is pi d raised to 4 over 64. Then, ano naman ang ating Q? This is equivalent to the area. Okay? Area multiplied by Y bar. So, area to ng top or bottom fiber. Ayan. Noong ating log. So, siguro top na lang gamitin natin. Pares lang naman sa top and bottom. So, ang area natin dito is pi. D squared na lang. Ayan. Wait lang. Kasi ang circle natin is pi r squared, no? Over 2 kasi semicircle. So, ang ating D kasi is equivalent to 2r. So, mangyari dito, or kaya na lang, pi d squared over 4. So, this is full circle. Then, divided by 2, magiging 4 multiplied by 2. So, this is pi d squared over 8 para sa semicircle. Ayan. Then, ano ang Y bar natin? Ang Y bar natin kasi rito is ito. Ayan. Ang Y bar is 4R over 3 pi. So, kung D ang gagamitin natin, ang R is equivalent to D over 2. So, this is 4D over 6 pi. So, this is 4D over 6 pi. So, cancel na natin to para madali. Yan. Kaya yung ating Q is equivalent to 4 over 8 multiplied by 6. So, 1 over 12. So, ibig sabihin, D cube over 12. Ayan. Then, ano naman yung ating V? So, yung V natin, subjected kasi yung ating log ng 40 kN, no? So, ibig sabihin, ang shear natin is manggagaling sa support. Yan. So, this is, let's say, point A or support A and then support B. Therefore, this is our AV and RB, which is equivalent to 20 kilonewton, 20 kilonewton. Kaya kapag drawing natin yung ating shear diagram, ang makukuha natin ng maximum shear force ay 20 kilonewton. Kaya yung ating V is 20 kilonewton. So convert natin into Newton. And then yung ating FB is 1.2 megapascal. So isa-isa na natin. 1.2 megapascal is Newton per millimeter squared is equivalent to V, which is 20 times 10 raised to 3 Newton multiplied by Q, which is D cubed over 12 over I. Ang I natin is pi D raised to 4 over 64 multiplied by B, which is also equivalent to our D. So simplify natin. This is what? D raised to 5, no? Then, tanggatin yung tatlo. So, this is D squared na lang. Ayan. Then, itaas natin yung D squared dito. So, magiging 20 times 10 raised to 3 multiplied by 1 over 12. Then, divided by pi over 64. Then, multiplied by 1.2. Ayan. And then, square root para makuha natin yung D. Na kung saan yung ating D ay naka-millimeters. So, 168.21. So, ang D natin is 168.209. 168.209 millimeters. So, ito, tama yung sagot natin if, no? If ang ating 40 kilonewton ay nakalocate sa midspan. Ayan. Pero, chinek ko yung problem, wala pa lang nakalagay na yung ating 40 kilonewton ay nasa midspan. So, ibig sabihin, ano lang, yung ating lag is magsusuporta lamang ng 40 kilonewton. So, possible siyang i-move or kahit saan siya pwedeng nakalocate. So, kung sakali man na ganun, ang gawin natin dito is tanggalin na natin yung word na midspan. Which is, mas maganda rin kasi kumbaga, ilolocate natin yung 40 kilonewtons sa position na kung saan makaka-receive tayo ng mas malaking shear. So, kung ganyan man ang situation ng ating problem, ibig sabihin, kailangan ilocate natin yung 40 kilonewton saan? Sa support. Kasi, doon tayo makaka-receive ng 100% na shear from the 40 kilonewton. Therefore, kung dito nakalocate ang ating 40 kilonewton sa A or sa B, ang marireceive ng ating AV is 40 kilonewton. Then, ang ating RB is 0. Then, ganoon rin. Kapag dito naman yung 40 kilonewton sa B, 40 kilonewton ng RB, 0 naman ang ating AB. So, ano mangyayari dyan? Ang ating 20 kilonewton is magiging 40 kilonewton. Pero kung kung nasa gitna talaga yung yung 40 kilonewton kagaya ng ginawa natin, tama yung ating answer na 168. So siguro na malikmata lang ako dun sa given. So ilan to? Siya ayan. So ganito siyang 40. Magiging sagot, then square root 237.88. Yan. Na kung saan ang pinakamalapit na sagot dito ay 240 millimeters. Then burahin natin to. Yan. Okay, so number 2, calculate the diameter of the lug need so that the allowable bending stress is not exceeded. So, kung yun nga, wala naman talaga yung ating 40 kN sa midspan, edi kailangan natin i-locate ulit yung ating 40 kN sa beam kung saan tayo makakuha ng maximum bending stress. And saan nga ba yun? Kapag single load lamang siya, makaka-receive tayo ng mas malaking maximum stress kapag yung 40 kN ay nasa gitna. Siguro copy natin to. And then, i-locate natin yan dito. Oops. Naka-incline siya, no? Ayan. So, yun yung ating 40 kilonewton. So, ito niyan, yung ating RB and AV is parehas na 20 kilonewton. So, ano naman ngayon yung ating moment? So, mag-moment lang tayo sa gitna. It's either sa left or sa right. Therefore, yung ating M max is equivalent to 20 multiplied by 2 over 2, which is 1. Kaya ang ating maximum moment ay 20 kilonewton meter. Then, bending stress. Ano ba ang bending stress? So, MC over I. Ano bang pinapakuha sa atin? Diameter, no? So, kung diameter, ayan siya, ang ating C is yung mismong diameter. Then, ang ating I is equivalent to pi d raised to 4 over 64. Kaya yung ating FB ay 6.3 Newton per millimeter squared. Yes, makita nyo rito magka-cancel yung Newton, ang matitira ay millimeter squared. And then, i-square root natin yung kaninang answer, no? Kaya square root of millimeter squared, millimeters ang makukuhang sagot. Ito naman, moment natin ay 20, so times 10 raised to 6 para maging Newton millimeter. And then C, which is D over I, which is pi divided by 64 multiplied by D raised to 4. So, cancel ang Newton. Cancel lang isang millimeters, no? Yan. Then, cancel na rin natin to. Magiging D cube. Wait lang, tama ba? Newton, millimeter. Yes. Tama. Kasi ito nga, naka-millimeter to the fourth to. So, tama lang. Millimeter to the fourth to. Then, ito, maging millimeter cube, no? Tama lang siya. Okay. So, ano yung ating D? Ang gawin natin is 20 times 10 raised to 6. Huwag na kayong mag-shift solve para di masyadong matagal. And then, divided by pi over 64. Then, multiplied by 6.3. Then, cube root. Asan ang cube root dito? Ito. Oops, 3. Then, answer. Ang sagot ay 401.4. Oops, 320 dito. Yung C nga pala is D over 2. Sorry, this is D over 2. So, this is D over 2. Then, pi over 64 multiplied by D raised to 4. Ayan. So, 6. Yan. Ito. Divided by 2. Then, cube root. 3. Answer. 318.59. 318.59 millimeters. Tama lang pala talaga. Na times 10 raised to 6 kasi nakabuo na to Newton meter. Yan. Then, cancel out to. Cancel. Cancel out yan. Okay? Then ito, tanggalin natin to. Magiging D cube. Okay, then, pinakamalapit na answer dito is 320 millimeters. Next, number 3. A 150 millimeter wide rectangular log is to be used instead of the circular log. What is the required minimum depth of the log? Okay, as not to exceed the allowable bending stress. So, same lang din dito. Nasa magbabago lang yung ating I and C. So, kung rectangular yung ating log, then let's say ang ating depth is H. Yan. Tapos yung ating width naka-given naman 150 millimeters. So, therefore, yung ating I is equivalent to 150 H cube over 12. Tapos yung ating C is equivalent sa kalahati ng H, which is H over 2. So, paras lang din dito. So, mangyayari ngayon, 6.3 is equivalent to bending stress naman, no? So, moment. Same lang, ang moment natin is 20 times 10 raised to 6 multiplied by C, which is H over 2. And then, ang ating I is equivalent to 150 H cube over 12. Then, cancel to, magiging H squared na lang yan. Okay, so 6.3, 20 times 10 raised to 6, okay, over 2, then divided by 150 over 12, then multiplied by 6.3. then square root of the answer. So, ang sagot ng ating h dito is 356.35 millimeters, or we can say that our h is equivalent to, let's say, 360 millimeters. So, ang sagot dito is 300. So, upon checking, ang ginamit niyang moment is 13.5, and we don't know kung saan galing 13.5 na yon, pero yung ginamit rin namin sa number 2 is 20 times 10 raised to 6. So, medyo nagkamali yata sila rito sa paglalagay ng moment. So, kapag 13.5 kasi nakalagay, ang lalabas talaga ng sagot ay 290 something. Kaya, pag na-round up natin, ang makukuha sagot ay 300 millimeters. Pero kung pagbabasin talaga natin dito is yung 40 kN at makapag-cause ng moment na 20 kN meter, ang makukuha sagot natin ay 360 millimeters. Ngayon, meron pang ibang mga shortcut, hindi nyo na kailangan pang mag-undergo rito, kagaya nito. Ayan. Sa shear stress, tapos dito sa isa-isang equation para sa I, sa C. Yan. So, sa shear stress kasi, yung shear stress natin is pwedeng 4V over 3A yata sa pagkakaalala ko. Then, yung ating bending stress naman, merong shortcut para naman sa sa rectangular shape. Ang equation nun is 6M over BD squared. So, double check natin. Yung ating ang pinapakuha dito yung D, no? Yung height. So, FB is, wait lang, ano bang given? Yung okay. So, 6 multiplied by moment, 20 times 10 raised to 6. Then, over B, ang B natin na 150. Then, multiplied by FB na 6.3. Then, square root natin. Ang makukuha sagot ay 356.35. Then, sa shear stress naman, di ko lang sure to, no? So, 4 multiplied by V. Ang V natin ay 40 times 10 raised to 3. Then, over 3. Ang 3 na, 3. Then, multiplied by FB, which is 1.2. Ayan, yun yung area niya. So, kung area yan, di ba, ang area ng circle is pi d squared over 4. So, multiplied by 4 natin, then divide natin ng pi, then square root. Ang makukuha sagot natin ay 237.88. Diba? Same lang. So, pwede nyo gamitin to syempre. Ako kasi, hindi ko lang masyado talagang memorize yung mga equation na to. Kaya ako, bumabalik ako sa basic concept ng strength of materials. So, speaking of strength of materials, yan nga, itong topic na to ay under sa bending stress din and shear stress ng strength of materials. So, you can visit our playlist under sa Chapter 5 ng Strength of Materials. And at the same time, no, in-applyan siya ng concept ng moving loads. Kasi sa moving loads, kailangan kayo yung maglo-locate nung single load, 2 moving loads or 3 moving loads sa span ng ating beam para makakuha ng maximum shear and maximum moment. Kagaya nito, kapag single load or single point load lamang ang given, makakuha tayo ng maximum shear force kapag ang ating load ay nasa support mismo. Then kapag naman single load yung ating beam at kinukuha natin yung maximum bending moment, kailangan yung ating single load ay nasa na. Okay? Ayan. So, simple lang naman itong topic nito and alam ko kayang-kaya niya yan. So, medyo malapit na tayong matapos sa ating CE board exam November 2022. Past board exam problems. Ayan. So, I hope na so far marami kayong natutunan sa CE Box tutorial channel. So, lubos kami nagpapasalamat sa lahat ng aming mga subscribers and viewers sa walang sawa ninyong pagtangkilik sa aming mga video tutorials. And syempre, papasalamat rin kami kasi alam namin na hinintay nyo talaga itong mga video tutorials namin sa past board exam. Kaya kami ay sobrang natutuwa at nagagalak na kahit na may mga buwan na hindi kami nag-upload ay talagang hinihintay nyo kami. So, thank you for watching everyone and God bless everyone. Good luck sa inyong review, sa exam, sa quiz, and also for the board examination. So, God bless everyone. Bye-bye!